Hey, how are you all people? Can you hear me? I see we have seven people watching this. So if any one of you can tell me, can you hear me well? Or would you mind me to, um, I don't know, move into the room? More light, less light, how are? Okay, I see you. Okay, that's cool. Thanks for the feedback. So you may be wondering, what are we going to do today? What's data image processing in Matlab, right? So I'm going to share my screen, and you will see what I'm talking about. But first, I would like to know how many of you have ever interact with Matlab. What's your level in Matlab? Can you understand matrix? Can you understand the comments, or should I explain all the code I'm writing it? So let's see what's the Matlab level here in the room. 1 of 10. Okay, don't worry. This will be like uh, um, this won't be a hard workshop. It's just you to know how you can do this in MATLAB, but there are also another tools you can use. For example, Python. You can use even JavaScript. I'm a JavaScript fan. I do JavaScript for work. But I think MATLAB comes with built-in integrations, so we can do this very quickly using the MATLAB environment. That's the reason. But okay, no other reason. I mean, even if you follow me on any other language, it will be great you to share with the other hackers that are here. So tell me when I am done with my workshop, you can send a message here like, "Hey, I follow you. I done this in I don't know, Rust, in Go." That was it's your preference. So let's start. Um, just let me put some branding here. Okay. Yeah, let's hide a little bit my name. We're live. Um, okay, now you can see my screen, right? You should be seeing, this is a lot of things I've been doing, playing around with the MATLAB environment. This is, for example, to detect borders in an image using Fourier transforms. I can talk to you about this further in the workshop, but let's open a new file. Well, the quick explanation here. You will see my file. It's called untitled .mlx, right? So what's the difference between an M MATLAB file, as you can see here, and MLX file? So you can think about it like when you do Python, yeah, a collab file for Python, you can run sections of code, right? The MLX extension here, it's for a live editor. So M extensions are the old MATLAB files. You can create here a MATLAB script. It's the classic one. But the MLX ones that are the live scripts have the advantage that I can easily, for example, split this uh, same document into sections or three or whatever I want, and run individually these three sections. So I can type here like e equals 0 and run this section, and we will see e equals 0. In MATLAB, we use CLC, clear all, and close all as a good practice for deleting every variable that we had in our workspace. So when I run this, you will see my workspace is clean. Then I can run this again, e equals 0, and run this section, and we will have this variable here with a 0 value, right? And over here, I can use like hello Matlab equal a string hello, right? And I can run this individually. And I can change this here to 1, and then run again the Matlab with hello 2. And you will see my value of the variable called hello MATLAB changed. It's now hello 2, but the I variable doesn't change, right? It's equal 0 because I haven't run this section yet. If I break this section and join them, I can run this and both variables changes. So that's the advantage and the main difference between using a live script and an old script. You will recognize a live script because here you can see live editor and the extension of the file. It's again MLX, and the old ones, I can create a new one here, for example, are just called editor script and has the .m extension. So I will going to close this and let me see if you have any comments at this point. Can see MATLAB window. Wait, I can see. Oh fuck! I've been explaining this. Sorry, let me do it all again, and I will verify I'm sharing my right screen. So let me stop this, and here I go again. Sorry for that. I'm really sorry. Okay, please tell me if you can see my screen now. Are you seeing the MATLAB editor? Okay, I'll do another thing. For those one who haven't had a MATLAB installed in their computers, I will show you how to do it with a live editor in the in Chrome or Firefox or whatever browser are you. Just let me share my screen again. Okay, you can see it now, right? Can you see? Yeah, I think you can see. So we will go to Google MATLAB online. Plenty schools have MathWorks, how to say it, like a MathWorks license. So you probably will be able to do this with your student email. But if don't worry. You can always follow me, as I was saying in the stream, or with any other language you want. So I'm going to click here and open MATLAB. Yes, and I'm going to create a new file. And all I've been talking at this point, it's just the difference between a regular script and these ones called live scripts, which are the MLX extension ones. But don't worry, I will repeat it again. So you can see here I have a file system, and I have this, for example. This is a normal script, regular script. I can double click on this and it will open, hopefully. Yeah, it's open now. So please leave in the comments if you're following me. Yes, okay, awesome. As I was saying, when I run this section of code, I will erase this. I can create a new variable called bar and equal, assign them to a zero value, right? If I run this code, uh, change folder. Okay. Okay. That's an issue here. I need to change the name of this file, but it will be better if I create a new one. So I will create two files. The first one is the LiveScript file, MLX, which I have for default, and the second one will be a regular script. Again, I create the script and I do the basic initialization for any Matlab file, which is to clear the workspace, clear all variables. This clears all the variables from the workspace. This one clears all the command window comments and close all closes all the files. How to explain? Closes every prompt we may be open for past iterations. So uh, again, I can just do this. I'm saying variable zero, run the code. I can call it test or global hack quick test. Save them, and I can see we have our value here for bar, which has a value of zero. I will do the same in the live script. CLC, clear all, and close all. And bar equal zero. And run it. You will see it's the same result. We have in our workspace a variable called bar with a value of zero. I was talking about I can split this same document in two sections. I will do this here, section break, and I can assign bar two, bar two with a value of two, why not? And run this individual code section here. You can see that it's separated from the other one with the color squares that are the background. So I can run this section, and my value has a name bar2 and a value of 2. You see there are two run buttons, right? The run, this runs the entire file, and this runs the section file, the section in the file. Sorry, I can change the value here to 1, and I can change the value here to 2 plus 2, which will be 4, and I can run this section. If I run this section, you will see only the variable in this section it's updated in the workspace. Even that I change the value here, it's not reflected in the workspace because this section of code haven't been run. So I can run the entire file and you will see that it's now updated here. That's the main difference between these two options that we have in Matlab, the regular scripts and the live scripts. Also, you can see I have to create this and give it a name and save it to run it. And with the live script, I don't need to do that. I just can focus on code, and which I will be doing here. So For the workshop, I'll be using an MLX uh, script. I'll see if you have any questions at this point. Okay, cool. I don't think you have any. Sorry, I just have to cough. Okay, cool. But so far, I will show. I have shown you what are the difference between the two file options we have in Matlab, but we don't have seen any of data processing, right? Well, let's try to do some about that. What is data processing? We call image or data image processing to read an image with any detection you want. It could be BMP or PNG or GPH. I don't know. There are many file extensions for images. This point, for example, the iPhones. I think when you download it to your computer, you get a Hake file. But whatever type of file, it means it's compressed in some way, but you see an image, right? There is more of an image in the file. There is data. The data constructs the image, and we can manipulate as hackers this data to do whatever we want. But first, um, we need to understand what are the color systems in which are these images are built. The first one and the most basic one that you will be probably very familiar with, it's RGB. With the RGB system color, you can use just three values and join them to form all other multiple colors. So all these systems are based. I will just project my face here because I don't think you need to see anything, and I can use my hands, right? And then I can share an image from Google. All these color systems are three times three matrices that we can manipulate. That's a cube, right? So if you want to see it like vectors, we have like the red vector, the blue vector, and the green vector, right? So in this point here, you can see the red, the blue, and the green. If you move yourself in this cube just in one vector, I mean, like you start climbing this one, you will get red in this point, red all over the edge, blue all over this edge, and green all over this edge. But what happened? I mean, not what happened. You know, when you have all three combined in this point, at point zero, you have white, right? 255 in red, 255 in blue, 255 in green. In the opposite side, 0, 0, and 0, you have black. If you have red 255, blue 0, and green 0, you will be in this spectrum. I can show you this with the cube to do it more graphically, right? Uh, yes, thanks. That makes sense. Uh, okay, you will see in images here. Let me find one. Okay, this one. In this, you can see what I was talking about. You have this blue corner, this red corner, and this green corner. And when you have all these colors combined in vectors, you have white. And when you have the opposite side, you have black. There's another color system that you may know, CMY, which is the opposite of the red, blue, and green, right? You can see C for cyan, which is this version of blue. You can see Y from yellow, and you can see M for magenta. Wait, yeah, this point. These two system colors are based on the color cube. But there's an extra one we will see in this workshop, which is a transformation of the cone of the cube to a cone. When we make this transformation, imagine you push this this edge, the red edge, and the blue and the green edges to make a circle, and you pull the black corner to make the cone ending. So we'll see that, which is called oh, I forgot the name. Yeah, let me check what's the name. I have prepared that here. Oh yeah, HSB. I was forgetting about that. HSB. Awesome. As you see, it's quite similar to the cube, but with a shape transformation. I mean, we still have the black corner, the white corner, and all the other colors. Like if you cone fell, if your cube fell, sorry, and it was reshaped. So in the HSB, it stands not for the colors, for example, in the RGB or CYM, it stands for these values. Like H is the hue, the value of the color we can choose. S it's saturation, the brightness we need, and B it's the value. So saturations comes from this vector to the end of the cone. Value comes from the point of the point of the cone to the circular face, and hue it's whatever color we want in this circle, right? That are the three color systems we are going to see in this workshop. Let me see if you have any questions. Okay, no. How do we do that? First, we'll make sure we have an image. I will open my file system and see I have an image that I can share with you. And find the path. Okay, yeah, I have it. So I will copy this and let's erase what we have done before, and we will create a variable called image and open it with the command read file. Read file, it's going to open this file path, right? And we will then have to show our image. Let's run that. Let's see what's the problem here. Oh, let me erase this. Okay. Read file is used in generate code to read a file. Okay, yeah, that's what I'm trying to do. I don't know what the problem is. Hmm. Let me check. I have do it live code. It's an extreme sport, so I was prepared for that. I have a folder with many examples here. Um, sure, we can use this. Let's see what's going on with our code. Just waiting to it to open. Meanwhile, let's see if you have any. Okay, no questions this far. Okay, here it is. It's open. So, uh, yeah, Ima, read, yeah, read, no read file. That was my bad. So let's run it again. Oh, it says this this one doesn't exist. Run it with the slash at the beginning. Oh my god, I copied that bad. Let's try another one, another image. I mean, and see. Uh, I don't know what it doesn't exist here. Let me see if I can just do downloads. Hmm, that will be a problem. We can run comments here. So cd to no just pw and run this section. We are here. My problem is that I'm in a folder which I'm not supposed to be. So I will just cd to uh, the right folder, which is this one, and open an image from here, which can be left image 0 and run it. Awesome. As you can see, Matlab has it's not a problem, but it's a thing to consider, which is if you don't put the semicolons here, you will get the output with the entire data. And I was talking about metrics, right? So the file it's storage in a matrix, which it's called IMA, and that IMA we use it to show the image. So here is the image as we can interpret it and we can see it, we can know what's happening. And here's the image, just raw data. And here's the file where I am. So I'm going to close this. Yes, that was the problem. I'm going to return here. And this image, it's just white and black, right? So we may want to search for another image. Let me do that. It's uploading. Okay, I have the image here now, so I can copy the name and open it. And this is not black and white. This is a full color image. But it's a little slowly in the mm, in the navigator. Just let's wait for that. Okay, here it is. What we need to do to get the RGB color system. The answer is easy because it is nothing. This image is being processed with the RGB color system. You want to show me? Do you want me to show you how I know that? Let's let's get the image, the raw data in this image. As you seen before, this EMA, it's a variable that contains the raw data for the image, and as we can transform and manipulate the data. So I'm going to create an error variable, which stands for the red layer that I want, and I'm going to assign it to IMA. We open this to tell Matlab that we want a specific layer of IMA, telling give me all that goes in the columns, all that goes in the rows, and just the first layer. And then I can show you im show error, and then we run it again. Oh my god, what is that? PWD again, and we can run it. What happened? We will do it right. Maybe this. And in some point I screw it this. Maybe I need to cd this, yeah, I need to let's see what's here. Oh, we are already in that, so no need to cd, and we can run it. Oh my god. Oh yeah, we need to cd it to this one. Yeah, yeah, that's fixed. I don't know what happened. To be honest, I think it's the same thing we had before, but sometimes MATLAB doesn't work that good. Let's wait to see the image output. I can close this actually. Meanwhile, we wait. We can. Okay, we have a J. I think that's good. Yes, this is the original image, right? So this is the red layer. I don't know if it's what you were expecting, like, hey, why then everything is on red? Well, that's not how it works. If we take just the red layer here, we can see that the skin, which is the object that has the most red pigmentation in the image, it's shown here with the lightest tones of gray, right? So we will see for the blue layer that it's the third one, sorry. We will see in the blue layer that the shirts here and the shirts here will have the lightest gray tone. So that's how we identify which layer are we on. And plus, we can even show this. And why not the green one? So, emo, comma, the second layer, and even show the green layer. Let's run this. That's the same again. I'm just going to cut this and paste it again. Maybe that's what Matlab wants. Fuck you, Matlab. Let's see where vision stereotypical images. Yeah, we are there, so no need to run it. Yeah, I don't know why it keeps me going and over again this, but let's wait to see our output images. Come on, MATLAB. Come on, MATLAB. Okay, I see this. Here they are. This is the original one. The next one here, it's the red one. Remember, the skin, which is the red pigmentation that has most color in it, shows that the skin it is the lightest gray. Then this is the green one. As you can see, no green. Uh, this really the part right here in the headsets. Let's Yes. Okay. So here you can see the headsets. This logo of the brand gets really white because we are on the green level on that. Differencing this little section here, you can see you can make a little comparison here. It's not that green, so it's not that a visual change. Let's see in the last one how the shirts different color, right? So see the first one and see the last one. You can appreciate it. Can you appreciate it? I mean, it's not that of in really I don't know. It's not that of maybe what you were expecting. Like if you take the blue layer, you were expecting to see everything blue and everything. But again, that's not how this color segmentation works. And when we combine this again, we can create a totally different uh, layer. Can be called IMA 2 that has in its first layer the air, and in its second layer the green and in its third layer, the blue, and we can print it. So m show EMA2 and run it. Come on, come on, come on. The expected output is to see. Oh my god, I forgot to put here the arguments. And as I told you, MATLAB shows all the data processing. So, as I was saying, what we expect to see here is just the same image as IMA because we build it on the same layers, red, green, and blue, that has the original one. So let's see. Let's wait to see what MATLAB show us. Okay, this is the original one. This is the red layer, the green layer, the blue layer, and finally, again, we have reconstructed the original one based on our first on our layers that we got. What can we do with this? To be honest, the RGB image processing color system, it's mostly used by uh, computational images. What I mean with that, not real images. If you take a picture and you try to process it with RGB, you will have a lot of problems with light. RGB system is very sensitive with light. So it depends in the environment in which you took the photo to see what colors you get. As I was saying, again, we can use the headphones, for example. You, as a trained human eye, can see this is slightly green, right? But you, as a not that well trained computer vision system, you probably have trouble trying to identify this color as green. Why is that? Because of the light in the environment here. So let's try to get another picture. Why don't we choose a Pokemon? So, um, Bulbasaur, which is a very green Pokemon that also has a, a little of blue that we can use, right? So I'm going to download this. Give me just a minute. Uh, okay, let's put bold the yeah and upload this to the MATLAB environment. Again, just okay, and the upload it's done, and we can change this to the bulb name .gpg and run the program to see what I was telling you. Oh, come on, MATLAB. You're slow as hell. But don't hate MATLAB. Don't hate MATLAB. I mean, as I was telling you, this is a pretty good tool to make image processing. Um, but not the only one. So if you're follow me this in this workshop, you maybe be doing this on any other uh, program language. So again, as I was telling you, to make a little recap, um, RGB color system it's used most with computer generated images. Real images are more processed in HSV RGB color system. And the reason mostly is because RGB, as I was telling you, is very sensitive to the light of the environment in which you take the photo or the video or whatever image you are trying to process. And HSB don't. HSB have the advantage that it's more sensitive to shapes. So for real images of the real world, that will be an awesome perk, right? But let's return to RGB and see with a computer image what's the difference. Remember, the first layer it's the red layer. We have here two red things we can um, identify quickly: the eyes and the mouth. As you can see, the eyes and the mouth in the image are the most light gray. It's now more easy to identify it than in the other images, right? So the green, I don't know if it's a shell or whatever thing it is here, it's in second layer, the most light gray we have. Again, as the skin, you can see here, the skin is it's pretty light because it's green. So here we have like a combination of green and blue, which will be the last layer. Uh, yeah, nothing to be really um, mm, proud of. I mean, we don't have much information for the blue layer, right? But the red layer gives us a lot of information of the color of the eyes, and the green layer gives us a lot of information of the color of the skin and everything else in this Pokemon. So I'm sure if we use other Pokemons, I don't know, like Squirrel, which is mostly blue, we can see in the blue layer a very big difference. And for the last image, we just reconstruct the original image we had previously on. So let me see if you have any question. Oh, that's cool. I hope you're enjoying it. Um, let's see the other system, which is, oh, I was forgetting. Comments here in Matlab are with this symbol, so you can use CMG here, and we can open it, and we can use like RGB here, CYM. How do we use CYM color system? In default, we this image right. So I was telling you that in the cube, we have in one system the red, the green, and the blue. The opposite part will be the yellow, the magenta, and the cyan, right? So again, let me show you just my face to do this. It's a vector system, right? Green, red, and blue. So the other one will be the other corner, the opposite corner. There will be yellow, that will be cyan and magenta. So it's easy if you think about it, because we just need to translate our value from one point to another. And how's that? Remember, values come from zero. A little clarification here in MATLAB, it's not a zero-based language, so it will be one. But for the only other real programming languages, zero, it's okay. From zero to 255. In this case, 256. Um, and we can translate the value that way. Um, I just need to see if email can I run this. Yes. As you can see, all our values have all our values in the matrix are from 255 to oh okay to 32, 33, 13, 26, 68, 100, 200, 47. As I was saying, from zero in MATLAB, no, from one, but any other language from zero to 255. Okay, so how do we translate this into the code? Let's close that. And we can say from the C uh, layer, which is the CN, we can take then again to the cube, the red, the red, and translate its value to 215, 255 points up and 255 points to the and 200, so here and 255 other points to this one to get here, right? I, I no, I don't want you, Bulbasaur. Close this. And I have an example here. Just wait to Matlab to open it. Okay. Oh, a file I made in case everything were bad and I won't be able to run code here, but I can show this later on. This is me in the last hack I had a week or two ago, but that's not important. Um, okay. Uh, this is the same. You can see that I've done this far. Okay, this is the code, right? So in the we can do this or we can do it other way because IMA layer one it's just the same to red. So we can do 255 value in the translation less the red layer. Let's see what happens with that in show. And let's see the um, and let's do it for the yellow one and the magenta one. So 250 less for the yellow one will be the green in show yellow one, and for the magenta it will be the blue. Right. So in show B. Oh, I don't know why I put this here, but let's run the code and see again what that bring us. Oh my god, I forgot to put semicolons here and here. Don't forget to put semicolons on your code. You will be prompt with this non easily uh, information to see. But again, no problem at all. Okay. Ooh, scary one, right? This looks, I don't know, I forgot. I, I messed up with names here. I need to change, so I'm going to run the code again. Let's see if you have any questions here. Okay, I'm glad you're enjoying this. I'm enjoying. Okay, Yeah, we have our code now. Oh no, fucking Matlab. Okay, again, original image, red label layer. Sorry, Uh, uh, red layer, green layer, blue layer. Reconstruct of the original image. This one right here, and we can see that it's not entirely PNG image. Oh yeah, it's JPG. That's why the background is all black. So let's see why this background is black and this background is white. Remember, when we have all the combinations of the color, all the values, zero, the green, the in zero, it's it's white, right? No, fuck, I'm forgetting about that. Yeah, yeah, I think it's white. No, no, sorry again. It's black, and with all the values, with all our combinations, it's white. Yeah, you can remember, as I remember, with the Led Zeppelin. No, it's not Led Zeppelin. It with the Pink Floyd album. Remember, all colors come from the white. So what you need to do to reconstruct white color is to get a combination of all possible colors. Yeah, that's how I remember it, and how you may be able to remember in future occasions. So. Uh, 255 values in red, in green, and in blue makes white. What's happening here that we have the white value, but we make a subtraction of 251 values of that. So that becomes a zero. And a zero in this color system are the black color. It means no color at all. Uh, so that's why in all these images we have the black background. But that same thing happened with all other little values of our matrix. If you remember, we opened the EMA matrix and we see we had values that comes from 0 to 255. If we subtract 255 to every single value in that, that means we changed the point on our cube that we will step on. So if we were step here, which is not here. Let me see the image that had both sides of the cube. Oh, I can find it now. Well, the other corner. We will step in the other corner, which had the green, the blue, and the red values. The corner that will be placed right here. And now we are step on this corner, which is the white corner, for example, that has the yellow, the cyan, and the magenta values on it. We first move 255 values to one side, then climb up 255 values on this side, and just return 255 values here. So that's that we do here. The interpretations are the same, to be honest, you will think. So, if there are much similar in that case, why we use CYM? Uh, you probably have seen, sorry, printer. In the printers, you buy yellow ink, magenta ink, and cyan ink. Yeah, remember that? Just again, my face. Okay. So you buy magenta ink, you buy yellow ink, and you buy cyan ink. You don't buy red ink, you don't buy blue ink, you don't buy uh, yeah, the green ink. But the reason is the background. The key is in the background, because for to get a white cover in the RGB system, you will have to use the three colors that we had in mind to create white. And paper sheets are white, right? So it will make no sense to print white on white. And with the CYM color system, you don't have to print anything to get white, because we change the point of we part again. So here it will be the other side. If you want to print black, you will have to put the different types of color: cyan, magenta, and yellow, to get black. But if we use RGB, you will have to put red, green, and blue to make white. And there, in when we print something, the most probably thing is that we want things to be as much as white as we can. Yeah. So for again, for images, computer generated images, we use RGB. For when we want to use these color systems to print something, to make like a photo album or something, even if you try Photoshop or um, tools like this, like, I don't know, Lightroom, the core system most used in that, if you want to make things for being printed, it's CYM. That's the main reason. But if you want to do things to be shown on a computer display or any other device display, you do the editing thing in RGB. But the last thing, and the last color system we will see in this workshop, is HSB, which is used to use data processing, image data processing, sorry, for real images. So let's do that. The last thing we will see is HSB. And how do we get HSB? Okay, let's see. Oh, I get Matlab, it's slow. We're running out of time here, so I will show you how to do this, because it's very easy. As you see here, HSB, thank God, Matlab comes with a built-in function to make the matrix transformation to get RGB. Oh, fuck, I messed up here. Okay, it's all fixed. Um, to make the RGB matrix transformation to HSB with this simple command: RGB to HSB. When we pass the original image to this function, it returns the matrix in HSB. And again, if we want to have just the H layer, the S layer, or the B layer, we can just do this, which is like splitting the layers in the first, the second. Oh, this is not bad. This is, oh yeah, it's still H. The S, it's the second, and the B is the, and of what we've seen this far. Let's see. Let's go with that. It's not that late. HSB, we can pass to HB use to RGB HSB We can pass the original image here, and age, it's HB, just with the first layer. We can even show this, in show age, oh, in show age, and the S HSB, to do. I'm just making dramatic noises. Um, I need to get focused when I code, because if don't, I just type nonsense. Sorry, guys. In show, and the last one we want to see, it's the B, which stands for value, HSB dot dot the third layer, and finally in show B. Okay, that's how we do this again. That's cool. For this purpose, I'm going to show the other image that we will using, real image that we used at the beginning. It's this one. And why I'm doing this? Because HSV system, it's meant to be for real images, real world images, data processing. So I'm going to run this, and let's hope for the best. Yeah, it probably takes a little, because remember, Matlab, it's not that fast on its online version. But let's see if you have any doubt or question at this point. Okay, it seems like you don't. But oh, I think everything's cool. Let's get back to the file. Okay, okay, okay. We have our images here. What happened? Let's explain it this way. Oh, okay, okay. This is B, this is S, and this right here, it's the H. We will see three different examples. This, which we code in real time, and this one that I had prepared. I love this image because it can show us a plenty of things about the color systems, mainly because it has a lot of colors. This is the original image, right? We have blue, we have yellow, we have red, we have purple, we have green, we have blue again, we have all colors. So let's jump directly to the HSV, right? Which is here. The first value, which is H, shows just the hue. Color system, all three values indicate us the colors or the combination of colors that we need to see to get the full picture. In this one, particularly, the hue stands for the color. So it's it's kind of weird, right? Borders not that a fancy thing. There's a lot of noise in our image. Many pixels even look like a dead image. I mean, like no separation between one pixel and another. And here, for example, you can see we have jump and jump, a jump pixel, like if we see it. And I'm going to tell you why. Remember the hue cone. HSP con. If you can see here, remember, hue, it's just the value here. And in the values here, we don't have either white or black. So what happened when we want to display this or black colors? Well, this is what happened. Mainly, the image says like, hey, I know this, you may think it's white, but it has a little tone of red, so I'm going to paint myself red tone. Or this has like a little of you may think it's black, but it's slightly blue, so I'm going to paint myself as blue. That's why here we have like this noise between pixels, because probably in the edges, which is the part in which have like more color changes, the image doesn't get enough data to paint itself. But itself, this layer, the hue layer, tells us a lot of things. But in complement with, for example, here, the saturation value. Oh, okay, yeah, the saturation, which comes from 0 to 1, or from really the center of the cone to the edge of the cone, it tells us how to see that edges. As um, Oh, a little clarification here. You may see that it's values from 0 to 1, right? I am inverting that because, to be more true, this image tells you which part of the image has a good saturation. That's the parts in black, the letters here, me, for example. Any other part in the image doesn't have enough good saturation. That's what they must say. Um, and the one minus here is to make it recognizable for a human A. Otherwise, it will be the other way. The background will be black and just me, and the letters will be white. That's the difference. So, in combination of these two layers, at this point, we can see what images have like the color, what tone of color are we looking for, right? So we have seen the color, but not just, for example, this green, but like this step of green, this type of green, like a lighter green. And part is the value, which is here. As you can see, it's like just black and white, but the value stands exactly for the white and black parts that we missed in our hue section. Sorry. Yeah, that is the part we were missing in our other layers. Mm, yeah, so that's everything. I don't know if you have any other question that you would like to cover. On Friday, yeah, on Friday, this next Friday, we will have like the second part of this workshop, and we will be using these color segment things to apply Yeah, we're back. Sorry, I just need some water. Oh yeah, as I was telling you, the this Friday we will have the second part of the workshop in which we will be use a color system, any of this, to see how we can transform the data in our matrix to learn how to recognize shapes in an image and use that shape um, to be in a process. Like if you have a soda can and it's like it has a little bump, so it's not that completely circular, you can take it from the process of like, yeah, the line of process, and it will be like image recognition, um, border detection and everything. It will be like three different types of border detection. The first one, you get a little spoiler at the beginning. It's Laplace transform. The second one, it's gradient. And the third one, I don't remember it well the name, but Matlab comes with pretty easy things to do that. So don't worry, talking about Matlab, I don't know if any of you guys follow or try to follow the color segmentation thing with any other language. I mean, at the end, it's just matrix manipulation. That you get a matrix of data, you you process it with a color segmentation style like RGB, like CYM, like HSB, or any other color, yeah, any other color system you want, and you transform the matrix. You give it different values to change it from one system to another. So that's so far that we see this leader workshop. Thank you for being here. Hope you see you soon, and hope you see you on Friday. I really like you enjoyed it. Thanks a lot, Dad Nugi. So, if you have any further questions, you can always try to follow me. I mean, try, because I don't know if for the regional things I'll be appearing in the searches. I'm from Mexico. I don't know where you guys are from, but you can try. Just type in Instagram or Twitter or whatever you want. This here is my here it's my nickname. And yeah, that's all. I'm going to end the broadcast, but first I'm going to put a little background with GitHub and everything. Sorry, Global Hack Week and everything. Uh, but that's all for today. Thank you a lot, and see you soon.